have those sort of, rules, like, and out and what we use on, so.
So let's go to rules. The sig fig rules, we have the zeros. So zero at end. Or trailing zeros, whatever you want to call them, only matter if there's a decimal. That decimal can be anywhere in the number as long as the zero is at the end. Okay. Zeros at the beginning never matter. Ever. They're called leading zeros. If I put something in a scientific notation, I never put a 0 point whenever, so it never matters. And then we have zeros. Always matter. They're like any other digit. 1, 2, 3, 4. So sig figs really mean that I know exactly what that code is. So if I have this number, okay, I have 6 sig figs in that number. Okay, every digit is a significant figure. All that means is I know that the 0 is a 0. I know that it's not a 1, 2, 3, or 4, i.e., it's not rounding up to a 1, right? I know exactly that this number is a 0. Okay, if I have this number, I am saying I don't know if that 0 is a 0. I could have rounded from all of those can turn into this number if I wanted to have 3 sig figs. That's all a significant figure is. It's just something that I know to be true. Okay, so we have those sig figs, and then we have decimal places. Decimal places are only addition and subtraction. These guys are multiplication and division. Okay, we have a number by itself to sig figs, but we're adding and subtracting anything in decimal places, and it's literally just the places after the decimal. You want to take, if we're doing any kind of equations, then we want to take a least number because you can only be as sure as your least sure number. Okay, sig figs tells how sure it is. The more sig figs, the more sure we are of that number. So start. I have it's probably like the third page, second page. Significant figures and rounding unit 1. That's what it says. So I have show me this or scientific notation. Okay. Great thing about scientific notation is sig figs were created to understand scientific notation and to use it because it's fun lazy. Okay. So if you see scientific notation, every number in that scientific notation is significant. You just need to count. 1, 2, 3. That's it. Okay. When I turn this into standard form, I keep the same number of significant figures. Okay. This number is big, right? That's positive. It's a big number. Okay. So I go that way, right? With my decimal. 1, 2, 3, 4, 5, 6, 7. Maybe got 13. Okay. Then we're done. So that's 6, 0, 2, 3, 4. That covers about 3, 4, 5, 6, 7. Yeah. Okay. So I have 10 zeros on that one. So that's how big the number is. That's what the real number looks like. Okay. I've kept 4 sig figs. A lot of people want to put that decimal at the end because we moved the decimal, right? But the decimal has to be invisible because if I put the decimal there, I now have 13 significant figures. Okay. So if I have a decimal, the 0 comes at the end, it's significant no matter where the decimal is. Okay. So if I want to go the opposite of 2 times 10 from negative, let's see, like now that's a number smaller than 1. Okay. So when I have scientific notation, if standard form number, right, which is just a normal number, if it is less than 1, then it will be a positive. That makes sense. Kind of do notation here. Okay. If standard form number is greater than 10, right, that's opposite, then you need a positive number. Right? This is positive, it means it's a big number. If this is negative, it means it's less than 1, bigger than 10. Okay. Do you guys know why I put the decimal there? In scientific notation? It can only have 1 digit and has to be greater than 0. Greater than 0, less than 10. Okay, same thing, kind of with the positive and negative. So just because it's a logarithm, that's what we're doing. Logarithms do groups. We're getting exponentially bigger. So if I do this one, I move my decimal this way because I want zeros in the front. 1, 2, 3, 4, 5. You just here, 0, 0, 0, 0. I put a 0 in front because I want to. But these zeros still are not significant. Because they are in front. I know those zeros aren't significant because they're not my scientific notation. Only significant figures are in scientific notation. Right? So that's my number. So is that good? Okay. So if I have this number, and I say I want 2 sig figs from that number, I want 2 round reduced 2 sig figs. Is that right?
0, 1, 2, 6.
I want 2 sig figs. Is that number the same as that number?
They're small.
No, much smaller, right? So I have to replace all of these with zeros. You have to keep how big or small the number is. That's what zeros are for. Okay, I still have 2 sig figs, right? But I'm just showing how big or small the number is. If that freaks you out, you can always do just scientific notation. If I turn that number into scientific notation of 2 sig figs, what is the number? It's a big number, so it's gonna be positive. Same thing. We kept only the significant figures. So if you run that standard form, right? So these guys, it's a lot about memorization and how to use it in the tricky spots. If I put that decimal there, now I have significant figures all the way through. That's one of the ones that'll get you. So they'll say, I want this number, but I want 3 sig figs. You can turn it into scientific notation, get 3 significant figures, of course. I can also just put a decimal. As long as you do not put a digit after that decimal, it is still 3 sig figs. How do you guys feel about the calculation?
Yeah, same. Same.
Addition.
Okay. The steps. The steps is a lot about writing down all of the information and not losing it. So. I think my brain's not started. So. All right, what are we gonna do first?
Parentheses.
Parentheses, okay? What is the rule for division? Sig figs or decimal places? Sig figs, okay? We have 2 in this one, 23 in this one. So our answer will have 2 sig figs, right? And that's gonna be a really small number. 0.0. I'm going to write down the whole number I get out of my calculator to start with. That is the number we're going to use for calculations. Now, right above this, wherever the operation is, I want you to write what it would be when you put those sig figs in. So I want 2 sig figs out of this. So what does it look like with 2 sig figs? Oh, you're putting signs from the view. I won't for now. 2, yeah. Okay. They're leading zeros, never matter. But I'm going to keep this for calculations. This is to let us know eventually what's going to happen. Okay, we're multiplying by 4. How many sig figs in 4? So our answer should have 4 sig figs. Right, but I'm going to keep our actual number. 8. Now, when I look at this sig fig and I say it has 1, if this had a lot of sig figs, this only has 2. This is 1. I'm not looking at this number for sig figs. Okay, this is just for calculations. Okay, so this is what I'm going for, but with 1 sig fig, it is 0.1. Okay, that is going to matter when I go for this one. Okay, if I subtract this minus 3.241, right? This is no longer sig figs. These are decimal places. I have 3 here. I have 1 here. Right? So what is my answer going to be? Okay. It's going to be a negative 3.12942. but I'm only gonna have one decimal place. That is my argument.
Yeah, I'm sorry, but after this, but at the 0 point where what number is that? No. That's right. On the boat, the two and the other is not. Well, okay, I mean,
A lot of it is just keeping track. Knowing what operations you're doing. These we're looking for sig figs and for decimal places. This one was decimal places, this one was sig figs. Okay. That's the tricky part. I will say, after we get done with this test that goes over this, you will never have to do subtraction and addition rules again. We don't care. Our numbers are too big or too small. We don't care. Like, I'll give you an equation that you'd actually, and then you probably. This is the mass percent calculation. Mass percent is, I have a certain percentage of something and something else, right? So let's say I have 9% white sand in 42 grams of this sand. Okay, and I want to find out how much of that mass wise is white sand. Okay, this is one of the calculations we do a lot. Okay, we do part over whole. Whole is going to be our 42. That's all of it. That's all the sand. 42 grams. Okay. Sand. Okay, and then I don't have a number for the weight of just the white sand because I don't know it, right? So do a mass percentage multiply by 100 because to get a percentage you have to multiply by 100 equals 9%. This is X grams white. Okay, this is an equation you will see a lot, especially right now. You might have already done it. So you can see here, I don't do with decimal places at all. This is multiplication division. Okay, you're gonna do a lot of these. Okay, this helps with conversions. Usually, this will be next to your conversion stuff. If you've already done conversions, you having it probably should already have. Okay, so we'll go through this one. I like to get rid of the 100 first. That's nasty. So I divide by 100. That just gets rid of the percent. I turns it into 0.09. And then to get x by itself, I just multiply by 42. Anything you do to one side, you have to do the other. All that has done is taken a percentage of 42. 0.09. Okay. So I have 3.78 grams of white sand. Is that correct sig fig wise? No. Always look at your question when it comes to sig figs. Don't look at what the conversion factors, don't look at whatever. Look at your question. We have this and we have that. So should I have 2 sig figs or 1? So what is the correct number? 4. Now, do I usually deal with 1 sig fig? No. Because that's not enough. You must want to be as specific as possible, but as lazy as possible for you. And then just do like that. So would I usually use the zeros or would I usually use 1 sig fig? But that is true to the amount of sig figs. So this is one of the big things. That uses sig fig rules for multiplication division. You also have something in lab called standard deviation. You're adding and subtracting there. People don't usually worry about it as much. Lab is a little, but lab is the most important when it comes to definitions because that determines the consistency. So standard deviation is usually like you have a let's say you did two rounds of an experiment. You got 1.23 grams or something. You would subtract that from the average. Or you would subtract the average. Let's say the average was 0.1. You square that. You just keep going. 1.34 squared. You only did 2. This is over 1 because it's here the number minus 1, the number of rounds you did minus 1. But this is one you're going to do a lot too. Thankfully, the influence is 6 rounds. Okay. When we subtract these two, we're going to take the least number. That's when we have to care about those decimal places. Okay. We're not caring about sig figs there, but everything else is sig figs. This is just multiplying something by itself. The sig fig. Square something or cube something. Do you guys feel about that?
okay, so does that one is square it, depending on number of sig figs?
So you'll keep the original calculation without rounding it, but at the end, yes. So, but putting it squared does not mean you have 1 sig fig, like for the squared. It's just by multiplying it by itself. So you just have to worry about how many sig figs you decided in here.
Okay, yeah, I'm just kind of curious about how you got Yeah, it's kind of sweet. Yeah, I'm kind of curious about how you square them up. Exactly.
How I squared them up. So this is the equation, right? The equation has to be squared. So if we did this, right, we would take these are our decimal places, so I would have 2 decimal places, and that would be 0. Not that's really the answer, but let's say it's that we rounded up to. So the actual answer would have 0 at the end, right? But when we do the sig figs, it has to be, we have to do the decimal place, it has to be 2, which means I have 2 sig figs here. So when we square it, our answer will have 2 sig figs. That's what I mean. Hopefully that can just confuse you. I know it's a little over.
So it's 0.1 the answer right there. 0.1.
Oh,
0.1. Is that the answer to that or?
yes. No, I didn't do that. No, absolutely not. No, it's 0.22. Sorry. Okay. Yeah, but I just want to show the difference between this will probably be the only equation that you use in lab, addition and subtraction, decimal place. Everything else is pretty much the same.
I'm sorry.
Go on.
I haven't worked with some of this, we haven't covered some of these problems yet. It might be, in my class, we had, the X, over the, yeah, that's why I was a little off on.
Yeah.
That, so.
So this is one of those math percent questions. I saw them in some of the homework. That's why I did that one. But if you've never seen math percent, it's just a fraction times 100. So, but these all go just for sig fig. There's no adding and subtracting. There's no decimal. So I just worry about sig figs there.
Okay. Yeah. So side I'm using Dropbox, the technical.
Yeah.
Also, all kinds of well, was having trouble with it because some of the budgets kind of makes sense on there, but then use valid places are saying some technology, like very complicated, it makes sense, it's not user friendly. If you've heard of this, if you've heard it, yeah. So yeah, so kind of have good problems with that. So I'm just be wondering if they're gonna put a bunch of stuff out.
That you don't know about yet.
Yeah, exactly. Yeah.
So your professors do have a choice about what questions they let on the homework. So they are randomized. So your professor will put them in a list and then back on what or a sheet, whatever you guys use, will randomize them. So but they have looked at all the questions. And so if they're confusing, you can always bring it up to them or me. But they are stuff that you'll have to know. So none of the stuff in there will be something you won't have to know, and they're just throwing at you. But some of it you might not see before, like in lecture.
Yeah.
Which is but I have a separate workshop for conversions, or I might, unless you guys really want to conversions, I can push that to the other one, and you guys can ask a question about your homework.
When's that?
Do you have the purple sheet?
Yeah,
Early February.
Okay.
Yeah.
Trying to see if I have any questions.
We'll get engaged in a second, so. Or lab questions, any questions you have, or do you want to go over
I want to take over.
conversions? Okay. Your labs or your homework actually probably will have conversion questions in it, and they're usually word problems. So the fact that you have in front of you doesn't do a lot of word problems when it comes to conversions, but a lot of the conversions you guys see in the homework are word problems. So like I saw one like an hour ago, and it said a 275 milliliter beaker weighs like 100 grams. What is different number, obviously. Like just don't give me the answer. For your question. But a lot of this is seeing what's actually being asked. So I have to go to the notes. So if I talk, so this is the volume, right? Do I talk about volume anywhere else in the question? No, I don't mention volume again. Volume's not important. Don't even get it. Just a beaker. Okay. I have weighs, and I said, what is the mass in kilograms? My original was grams, go to kilograms, it's the straight conversion. Okay. I always start with what exactly I know what they told me. So mine looks like this. Some people looks like this. Do whatever you want to do. I've always done the ends. Okay. So the aim of conversions is to cancel out what you had before and then go to the next one. So this one is technically on top. Third fraction is little whatever, every whole number is over 1. So if I want this grams to go away, I have to put grams down here. Top, bottom, cross it out. Just like a variable. And if I want to go to kilograms, I can go straight to kilograms from grams. Do these things. Okay. Which one is bigger? Kilograms is bigger, so it's the one. I do like, the bigger one is a bucket, and how much of the little ones you have to put in to fill up the bucket. So kilo is 1,000. 1,000 grams. Okay. Because the ones aren't going to change anything, you're just dividing. Right? So this is really 1,000. Should just be a smaller of this one. If I asked, I say this is a big ask for different reasons. Huge. Oh no. What does that stand for? Micro. It's a U. It's got U. Anyway, so if I have kilograms to micrograms, right? Then what I have here is a multi-step conversion. Okay, this used to be called dimensional analysis. Sometimes it's still listed. Okay, so we still start with what we know. Okay. I still want to get rid of kilograms, so kilograms will hold in the bottom. And I always really want to go to my base unit. So I'm going to go to grams. I don't even care about numbers yet. I'm just going to set it up. Okay. So I still want to get rid of grams because it's not my end product. So grams goes on the bottom because it was originally on the top. Okay, and then I can go to micrograms. Okay, I usually set them all up even before putting numbers on, just to know, because I got rid of kilogram, top bottom, gram, and I'm left with something I didn't cross out, and that's supposed to be my end goal that I've done. Okay, so we said kilograms bigger. What about micrograms? Grams, which one's bigger? Grams. Something is called micros. That should probably. Micro is 1 times 10 to the 6 or a million, whichever one you want to write. Obviously 1 times 10 to the 6. Just because I remember that, and the nano is 1 times 10 to the 9th, it's a billion. Sometimes you see these, and it is right. Sometimes that's written in your notes. Okay, so what they've done here is they've taken a fraction of a gram equals 1 microgram instead of me saying 1 gram equals a million micrograms. 2 ways to write it. I don't know which one to write. Usually this freaks people out. I never use it. But cosine especially. Yeah, dash lines. Yeah, you can do this. I don't care which one you do. But I usually do always the bigger one gets the one. Because I like buffalo. Okay. So if I have micrograms at the end, I'm done. And what this really looks like. Right. Do you expect the number to be smaller or bigger than what we started with? It'd be bigger, right? It's like going from a huge unit to a tiny unit. So I need a bunch of tiny units to fill my big unit. If you guys have trouble with your scientific notation and your calculator, please put parentheses around it. Your calculator won't break them up. I'm gonna keep as many stick fixes as I have, right? So I keep that 0. So I should talk. Meters. That's great. Okay. Anyway, so grams is obviously mass, meters is length. Like constant volume. This is another one I saw in your homework, so I got cover it. This is also like the definition of dimensional calculus when you do. So I want to do, so this is what cubed looks like. Right? 1 meter equals 1 meter cubed. Right? We get area. Because like x width equals area. This is 1 meter. That is the difference. You're not multiplying anything with just a meter, you're multiplying anything with a meter squared. Okay. So when we have a meter squared, we have to, or anything squared, we have to multiply the number that it's been. So let's say I have 6.98 meters squared, and I want to get 10 kilometers squared. Right. So if I have meters squared here, I have meters squared here. I have to get rid of it. And then I know I have no kilometers squared. The tricky part about this is if I have a squared unit, I have to square the number that it's been. Okay. So normally, which one's better? kilometers, so that's 1,000. These numbers are still 1 in 1,000, except we have to square both of them, because they have square units. Obviously, what's very small. That was a spreadsheet. So this looks like. So that is really. By. Good and small. I can go ahead and stick like that. And that would be kilometers squared. If I want to put that in my notation, what is it?
Would be 6.98.
Is our exponent to be negative or positive?
Negative 6.
Feel free, units. There's my thing under homework where you're sitting at something that's cube. You do the same thing, just cube it. We don't have to cube the initial one because it's already been given to us in meter squared. How do you guys feel about the standard conversions? If I see already non-metric.
We're talking about like the standard form of the code, we're talking about the orthogonals.
I'm talking about like feet, inches, yards.
I use some cracks on that.
So a lot of these we expect you guys to know if you are not from America or I do say non-American students, sometimes they might not talk to their professors about what they need to memorize and what will be on the test for standard. Because I have a lot of like Eastern European students, a lot of Middle Eastern students. I'm still not standard. I'm maybe not standard. So usually I have a packet of standards because I like the standard ones to get through back and forth. Sometimes they'll be mixed standard and metric, which I think I'll do. So 4 miles. Okay. I want to get to kilometers. What's our first thing that we do? Can I go straight to kilometers with the front of your packet? I put all sheets up there. Can I go straight from miles to kilometers? Yes. Because I gave it to you. No one expects you to memorize this. So they might ask you how many feet in a mile. So that gets us to kilometers. That's a straight conversion, just one step. So we're just multiplying that miles by that kilometers. How many siblings is your answer gonna have? Do we worry about conversions happening? So this is the conversion factor, right? Do we care about the same things in the conversion factor? No, it's the fact. Okay. So we don't put that up to 8. So we just put the number we've been given, so we'll have 5. And you do that. You guys want to. This is one of my favorites. Okay, so this is usually a word problem. My cat's name is Cat, so I'm not really good. So I'm not kidding about that. I'm dog no name. We call it guy goes 112 miles per hour. Okay. How many minutes? Oh, yeah, this is one go on longer. Everyone's 26 miles. So I give you miles, but I'm gonna give you. Okay. So I have given you a lot of conversion factors, you just can't see them yet. Okay, so guy goes 112 miles per hour. That's insane. I just realized that. He's like so fast, yes. So 112 miles, if I say per. That's what that looks like, that's conversion factor, right? So with these, because both bottom and top need to be converted, right? I need to convert miles to meters, I need to convert hours to minutes, okay? You just need to pick which one you want to do first. Which one do you want to convert first? Miles to meters, okay. So miles goes down here. Can I go straight from miles to meters? Let's say I can. Let's do the kilometers. So I remember that. In 1 mile, there are 1.609 kilometers. That's all the path. Okay. So I've got rid of miles, but I haven't gotten meters, so I'm still going. So what goes on bottom? What goes on bottom? We haven't finished. Oh, kilometers. What goes up top? What are we converting to?
Meters.
Okay. Kilometers is done, and meters is gone, or meters we have, so we don't mess with meters anymore. Okay. So we have to do hours. Hours is on bottom, it goes up top all the way up here. Okay, we're going hours to minutes. Do you know how many minutes are in an hour? Yes, so we can go straight to minutes. Okay. Cross out minutes or cross out hours. And I've got meters per minute, which is exactly what I want, okay? So you always go multiplication, then division, multiplication, then division, multiplication, then division. If you don't put it as one fraction. You put it as one fraction. You do 1,000. And then we have 1 cubed. X times 3 1 times 2. So actually, okay, this number. Okay, so that's obviously repeating. Okay. How many signifiers should this have? Version factor. Version factor.
Should have. Still 3.
Okay, so I'm gonna write over here what that would be. Oh, it would have to be a second notation. Okay. Oh. Because it's per hour. It was always been one. It's always been one. Alright. So this is meters per minute. Is that my answer? No. I don't want to know how many meters he runs per minute. I want to know how long it takes him to run a marathon. Okay. So this looks like this. Right? How do I get rid of meters when I'm doing this kind of stuff? It's up top.
We're gonna use. You have to divide years and minutes.
You do have to divide, you have to divide by meters, right? So this is my pace. Okay. I want to know how fast it took for him to run a mile. Okay. Now I need to find out in meters how much he ran, right? First. Alright, kilometers up here, right? I'm just keeping moving over there. Alright, I'm just converting to meters so that I can use that number. So if I say 20. So he ran 41834 meters. Okay. So here's my big number. Now I want to know how fast he ran it. So I have to divide by my rate. We divide distance by rate. Okay. If I do this, I get rid of meters, don't I? And I just have minutes.
If you gotta go to, sorry.
Do you think that's right, John?
Does he? Sometimes you know you're basing it, because with you right now, you know what? What's I was saying, please don't erase.
Absolutely, I was gonna erase it. You're good. Then we divide by that 303. Wait. What I get is 13.9287. Which is impossible, by the way. Okay. Can I ask how many sig figs would be in this number? We're done. This number, we're looking at 3 sig figs, right? This number is 1, 2, 3, 4, 5. So our total should have 3. 13. It usually takes a whole day to run a marathon. Well, give it 6 mile. That would be 10 miles per hour. I really don't know. But he's not endurance. I know that was a lot of work. But usually these guys have a lot of kind of but that's like a 400 kilometer. So I wonder if he could do that for a while. Cause I can't imagine, like, he's not a marathon runner. I wouldn't. The original marathon runner, the original guy who ran, to tell him about Paul Trophy Park. He was, I think he ran both days. And then he died. Okay. Do you have any questions?
Well, before we go, I just have a couple of questions to answer for my lab.
Go ahead.
Yeah. So it's about some forming of the mathematical still with, so it's forming the number operation with the sig figs and already design. Right.
It's like, yeah.
Yeah, so. Circle, I missed so.
So